I have started the recording. Today we are going to go through arrays. Let me paste the link to the OCaml docs page. So under language tab, we went through options. So today we are going to go through arrays. So let me paste the link to you on the chat. Feel free to ask any questions you have, and we'll get started. So in OCaml, arrays are collection of elements of a single type. Arrays can be mutated. We'll see some examples of that, but they cannot be resized. Okay. They are of course very efficient to access elements at any position. So primarily arrays in OCaml are used for storing and processing large amounts of data, for use in algorithms that require random access and you want to modify the elements, also for working with matrices and other multi-dimensional data structures. So let's look at examples. So in OCaml you have to use the square parenthesis and the pipe symbol to define an array. So let me start utop here. Okay. So we can define an array as 1, 2, 3, 4, 5. Okay. Now you can also use the array.make function, which takes two arguments, the length of the array and an initial value of the element. So let's see what array.make definition is. So it is the length of the array, an initial value, and then it returns a array here. Okay. So let's use it to create a zeros array. Array.make, length of the array is 5, initial value is 0. Right? So we have a array of 5 elements whose values are 0. Now you can also use array.init. This will generate an array of a given length by applying a function to each index of the array starting at 0. So in the following example, we are creating a even numbers array which consists of the first 5 even numbers, and we are passing it a function which doubles its argument. Right. So let's try that. Even numbers array.init, 5 elements, each one we are saying I into 2. Okay, so we have an even numbers array of 5 elements which has the value 0, 2, 4, 6, 8. Now how can we access the array elements? Right, you can use the dot and within parenthesis index syntax, and the index of the first element is 0. So you always start with 0, and the index of the last element is 1 less than the size of the array. So if you want to find out the third element in the even numbers array, you just do even numbers dot within parenthesis 2 and we get 4. And this is the third element. Right. Now as I said earlier, we can mutate the array. So you can modify the array by specifying the index operator. So here if you want to change the third element in the even numbers array, we can do something like even numbers of with the third element, just say 42. Now this operation returns unit, so it doesn't create a new entry. So if I look for even numbers again, it's an in place change, right? It doesn't return the modified array. So you must remember that. Now let's look at some standard library, the array module functions, some common ones that are frequently used. The first example is array.length, which will return the size of an array. So I want to find out the length of even numbers array, this 5. Now we can also iterate on the array. So array.iter will apply a function to each element of an array one at a time. Okay. This function must return unit as a side effect. An example here is to print all the elements of the array zeros. So we can use the print int function on each element. So let's try that. Let me clear the screen on UTOP. So now I can do array.iter, takes a function, we print the argument x, print a empty string, we pass the array, and prints the values here, right? Now you can also iterate on arrays using for loops. So let's try this example here. So for I is equal to 0 to array dot length zeros minus 1 do, let's do print int zeros of I, and then we just print string, and then we call done. Okay, same output. Now using a for loop. Now the next array function is map. So the array map function will create a new array by applying a given function to each element in the array. So let's do array.map. We pass an anonymous function, and for each element we just multiply it by itself. Okay, so we get the result. So here we get an array containing the square of each number. So since we modified the third element to be 42, the square of that is 1764. Now we can also combine all the elements of an array into a single result. So this is the fold operation. So most of the functions that we have seen in the list module can also be applied in the array module. We have similar functions. So we have array.fold left and array.fold right. These functions take a binary function as an argument, an initial accumulator value, and an array of arguments. The binary function itself takes two arguments, the accumulator's current value and the current element of the array, and then it returns a new accumulator value. So let's see the definition of these two functions. Fold left, I mean the same functionality, but just that they traverse the array in different directions, opposite directions. Okay. So as given here, fold f function, initial accumulator value and the array, it computes from 0, 1 till n minus 1. And similarly, if you look at fold right, it just switches the order of its parameters. from n minus 1, it computes till f of a dot 0. So these functions derive a single value from the whole array. So we are basically doing a fold operation. So an example here is to find the maximum element of the array. So if we look at even numbers, this is the current elements. So if we do array dot fold left int dot max, it's a max function, min int initial value, and we are passing the array, and it returns 42, which is the maximum value in the array. Right. Now you can also sort the array. So we have the array dot sort function. This function takes two arguments. So we have a comparison function which is used to compare the elements of the array and the actual array itself. Right. So it sorts the array in place in ascending order. Again, the modification is done. This is a side effect, so it returns unit. So let's see the example here. Let's first see the definition of array dot sort. So it takes a function is used for comparison, the array itself, and then it returns unit. Okay. So we can call let's see what is even numbers first. Now we call array dot sort compare function on even numbers, and now we check for even numbers. It's now in sorted order, in ascending order. This is an in place side effect change. Now you can also copy parts of an array into another array. So we have the blit function in the array module to copy a contiguous part of an array into another array. Again, this modifies the destination in place and returns unit. Okay. Now let's see an example of copying once in an array. So let's create a once array. So this contains 5 elements and each element is the number 1. Right. Now let's look at array dot blit, what it does. So it takes an array, an index, it's like source index, this is destination, index, and number of elements. Right. We could use like type aliases to make it more meaningful. So now we know the functionality of the blit function. So from once array, from 0th index, copy to zeros array from index 1, 2 elements. Okay. Before that, let's see what is there in zeros. So it is easy to compare. It's just zeros. So now let's do array dot blit once zeros 1 2. Now if I check zeros, so what this has done is from the 0th index 2 elements, it is copied to right from the ones here 0th index, it is copied to zeros from the index 1, that is 1 1. Okay, that's the result here. Now that's what is described here. It copies 2 elements of 1 starting in index 0 which is this one, into 0 starting in index 1. Now, it is our responsibility to make sure that the two indices provided are valid in the respective arrays, and the number of elements to copy is within the bounds of each array. So, we have to ensure that these constraints are met. Now, we can also use this function to copy an array into itself. Right. So, let's we have zeros here. So, what I want to do is this execution here, from zeros, from index 1, I want to take 2 elements, copy it back into zeros starting from index 3, which is these 2. Okay, I want to replace this. So, let us try that. Array dot blit zeros 1 zeros 3 2. Now, if I check zeros, we see that these 2 elements have been copied to index from 3. Okay. That is the blit function. So, we have covered the basics of arrays, how to create them, how to modify them, and some useful functions and use cases. Now, you can refer to the standard library documentation to look at more functions that have been defined here. So, try to create examples, see the definition, the type signature, try like append and so on as homework exercise. Okay. Let me paste the link to the YouTube channel where I will make this recording available, and also I have pushed the notes from today's session as well, so you can go through that as you practice the videos and the exercises together. So, this is a link to the videos. Let me paste the link to the notes, which you can refer here. So, with that, let me stop the recording.